All right, today's lesson is on 8.3, which is combustion. Now, we have talked about combustion in Unit A as well when we were looking at different kinds of chemical reactions. So, a little bit of review. Combustion, it's a chemical reaction that takes place when a substance combines with oxygen. So, when we're looking at fossil fuels, energy stored in fossil fuels is converted to thermal energy by combustion or burning. Um, it happens quickly with fossil fuels, and then thermal energy gets released. For example, propane. Propane is a fossil fuel and is used for immediate heat. It's one of several gases that can be separated from natural gas, and combustion of propane provides thermal energy to heat houses, cottages. It's used to cook foods in restaurants, and also those tanks for barbecues. It's also used to run some motor vehicles, and the chemical symbol or the symbol for propane is C3H8, and then we have that lowercase subscript of G showing that it is a gas. This is just the chemical equation as well as the word equation showing what's happening during the combustion of propane. So propane gas plus oxygen gas produces carbon dioxide gas plus water vapor. So as you recall, combustion reactions always require oxygen gas, and the product will always be carbon dioxide gas and water vapor. So in this case, propane has the chemical formula C3H8, combines with 5 molecules of oxygen, produces 3 carbon dioxides and 4 waters in the form of gas. And complete and incomplete combustion, we talked about this in Unit A as well. So first of all, hydrocarbons, these are fossil fuels that are made up of carbon and hydrogen. So the hydro comes from hydrogen and then the carbon for carbon. When fossil fuels burn completely in the presence of oxygen, they will produce always carbon dioxide gas and water vapor. So complete combustion ensures the maximum amount of thermal energy, and it also ensures that carbon dioxide is produced. If combustion is not complete, then this poisonous gas is formed, carbon monoxide, which is just CO. So carbon monoxide is a poisonous gas. It's dangerous because it's like odorless and it is lethal. Just a couple notes here about carbon monoxide. It is dangerous to use a gas barbecue or an unvented propane heater indoors because there's less oxygen available indoors than there is outside. Also, the reason being is when there is little oxygen and you use those indoors, like the unvented propane heater, if you use that indoors where there's little oxygen, the combustion is not complete and that deadly carbon monoxide gas is produced. These two pictures here on the left, the blue flame is showing a sign of complete combustion, and then in this flame here, it's a smoky yellow flame. It's indicating incomplete combustion. This is showing that the flame is not getting enough oxygen. Next is the similarities and differences between cellular respiration and combustion. So in this example, it's showing combustion of methane, and then we're seeing the top equation here for cellular respiration. So again, body cells get their energy from the process of cellular respiration, and it is a similar process to combustion. So if you look here, both processes require oxygen, and both of them are producing carbon dioxide, both of them are producing water, and both of them are producing energy. A difference between the reactions is what happens to the energy. So in combustion reactions, it's thermal energy being released. In cellular respiration, the energy is used to produce chemical energy for the body, and only a small amount of it will be transferred into thermal energy. Another difference between the two is the rate at which the two reactions occur. Combustion will happen very rapidly, very quickly, while cellular respiration is a much more controlled and slow process in the body. All right, so that's it for 8.3 on combustion. So make sure you know the difference between combustion and cellular respiration, the difference between the two and the similarities between the two. Also make sure to know the difference between complete combustion and incomplete combustion.